Right, let's have a look at elimination reactions. So we have elimination reactions that essentially when we take away two atoms or an atom in a group from an organic compound, and the places where those substituents were removed are going to turn into a double bond. Now, usually in this level, we are looking at what we call haloalkanes, that is chlorines, bromines, fluorines, iodines attached to a carbon, or alcohols, that's an OH group or hydroxy group attached to a carbon. So what we do is we remove one of those groups and an adjacent hydrogen. So here's two examples here that we can see. So here is a haloalkane. We have a fluorine, and what we're going to do here is we are adding potassium hydroxide. We could also add sodium hydroxide. Now in this case, to make this work as an elimination reaction, the potassium hydroxide has to be dissolved in alcohol and not in water. So we're using this reagent. What it will do is it's going to remove a fluorine that is attached to a carbon, and then remove a hydrogen from the adjacent carbon. And in this compound, the only adjacent carbon is the carbon on the left here. So we're going to remove this fluorine and this hydrogen. When we remove these two atoms, then what happens is a double bond is formed from the carbons that were removed from. And here we have. So you can notice in this example, there's only one way that this reaction can happen when we carry out the elimination. Notice here also there is an additional product that's produced, hydrogen fluoride here. These are the two things that have been removed and joined together. So let's have a look at our second example here. In the second example, we are adding concentrated sulfuric acid. Now, you might not know, but concentrated sulfuric acid has an affinity or really loves water. So it will try and take water away from any compound that we put it with, or it would dehydrate anything. So this is why we call the removal of an alcohol group and the hydrogen group from an alcohol a dehydration reaction. It's a type of elimination reaction because it's removing a water molecule. So essentially what happens here is we remove the OH here, functional group, and hydrogen from an adjacent carbon. In this case, there is either the carbon on the left or the carbon on the right. Now, because this molecule is symmetrical, it doesn't matter which one we remove it from. So we are going to, in this case, just remove it from the one on the right, and we'll produce this molecule here, which is propene. It has a double bond off the first carbon. It's also going to produce this product, water, that the sulfuric acid is becomes involved with. It's a combination of the OH and the hydrogen. Now, what's important with these types of elimination reactions to know is the following situation. And the following situation is when we have to use Zaitchev's rule. Now, Zaitchev's rule is that, look, if we have to remove either the halogen or the alcohol substituent, then the hydrogen is going to be removed from the adjacent carbon. We saw that in the two examples we're given. But the hydrogen that is going to be removed the most of the time is going to be the hydrogen that has the least, that is attached to a carbon, has the least hydrogens attached to it. So let's have a look at this example here. So you can see that there is a chlorine molecule, substituent atom attached to this carbon. Now there are two adjacent carbons. There's the one on the left and the one on the right. Now adjacent, I mean the carbons that are joined to the carbon that's joined to the halogen. Now the one on the left is said to be poor. Now the reason we say it's poor is because there are two hydrogens attached to this adjacent carbon, where the other adjacent carbon has 1, 2, 3. So this chlorine, okay, the functional group, the carbon that is attached to, if we look at the two carbons that are joined to it, we identify which one is poor and which one is rich. In Zaitchev's rule, the general idea is the poor get poorer, That is the one that has the least hydrogens. The carbon that has the least hydrogens attached to it is the one we're going to remove the hydrogen from. So in this case, the poor one is the carbon on the left hand side. So we are going to produce this product here. Okay, so we're going to make a double bond in the middle here, and this is going to be butene. This is the major product. Now remember, because there are two options, so there is this poor option, or the one on the left hand side where there's only two hydrogens attached, or there's the one on the right hand side where there's three hydrogens attached, the rich one. This one happens less often and produces the minor product. So because there were two different options that would produce two distinct products, different products, we use Zaitchev's rule to work out which one is the major product and which one is the minor product. And remember, Zaitchev's rule states the hydrogen atom will be removed from the adjacent carbon with the least hydrogen atoms bonded to it. The poor gets poorer. And that's elimination reactions using Zaitchev's rule. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.